Hello everybody, we're getting ready to do Chapter 7, Classwork, Lesson Part 1, SAT Math Level 2 Prep, 14 points on your notebook guide, Chapter 7, Trig Functions, Part 1, and then 10 points on your classwork sheet, so mostly taking notes, name, date, period, in my class, due date, onliners, homeschool. Page 1 of Chapter 7, Part 1. The general definitions of the 6 trigonometric functions are obtained from an angle placed in standard position on a rectangular coordinate system. When an angle theta is placed so that its vertex is at the origin, its initial side is along the positive x-axis, and its terminal side is anywhere on the coordinate system, it is said to be in standard position. The angle is given by a positive value. So here is an example here. Here's theta. Here's a terminal side here. If it is measured in a counterclockwise direction, so if we go in this direction, it's positive. This direction would be negative. From the initial side to the terminal side. And the negative value is if it's measured in counterclockwise. So we go, in a clockwise, it's negative. So this would be a negative theta, and then this would be positive theta. This would be a positive theta over here. So let P of x be any point on the terminal side of the angle, and let R represent the distance between O and P. The 6 trigonometric functions are defined to be sine theta will equal y over r, cosine theta will be x over r, tan theta will be y over x, cotan theta would be x over y, secant theta would be r over x, and then cosecant theta would equal r over y. From these definitions, it follows that sine theta times cosecant theta will equal 1. Cosine theta times secant theta will equal 1. Tan theta times cotan theta will equal 1. And then cotan theta equals cosine over sine theta. If a perpendicular is constructed from P to the x-axis, a right triangle is formed by the perpendicular, the x-axis, and the terminal side. Dividing both sides of the Pythagorean theorem, x squared plus y squared equals r squared, by r squared yields the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. The following identities, sine squared theta equals 1 minus cosine squared theta, cosine squared theta equals 1 minus sine squared theta, and 1 plus tan squared theta equals secant squared theta. Cotan squared theta plus 1 equals cosecant squared theta. That's where those come from. The distance OP is always positive, and the x and y coordinates of P are positive or negative, depending upon which quadrant the terminal side of angle theta lies in. The signs of the trigonometric functions are indicated in the following table. So when you are in these 4 different quadrants here, here's your signs of your different trigonometric functions for that. Positive, positive, negative, negative for sine and cosecant. Cosine and secant are thusly, and then tan and cotan are thusly here as well. Each angle theta, whose terminal side lies in quadrant 2, 3, and 4, or 4, has associated with it an angle called its reference angle theta, which is formed by the x-axis and the terminal side, like this. Here's theta here, reference angle, will be theta r. They call theta r here. This will be theta r, which is your reference angle. from your x-axis to this angle here, and then theta would just start from the initial side here and go like this, whereas this is your reference angle. There are two different angles in this situation. Any trig function of theta equals plus or minus the same function of theta reference. The sign is determined by the quadrant in which the terminal side lies. So this quadrant here is quadrant 3. So you have negative x's here and then negative y's here as well. This would be a negative y and then this would be a negative x. So it'll be positive. So the angle here, see, the sign is determined by the quadrant in which the terminal side lies. So the trig function of theta here, you'd have a negative x and negative y, so it'll be a positive in quadrant 3. And A, express sine 320 degrees in terms of theta reference. So here's our 320 here. We go all the way around like this. Here's our reference angle here. Our theta reference would be this angle here. And then here's theta here. So theta reference would equal 360 minus 320 would be 40 degrees. So you have a 40 degree reference angle here. Since the sign is negative in quadrant 4, so we have a negative y here, sine 320 degrees would equal to negative sine 40 degrees is what that would be. The sine would be a negative 40. And then B, express cotan 200 degrees in terms of theta reference. So here is your 200 degree angle here. This is your theta. This would be 200 degrees. What would this reference angle be here? So it'd be 200 minus 180. It'd be a 20 degree reference angle here for this total theta. You'd have a reference here of 20. So it'd be 180 plus 20 more would be 200. Since the cotan is positive in quadrant 3, the cotan 200 would equal cotan 20 degrees here. So cotan would be the opposite of tangent, so that would be a positive angle in that situation. Why? Because they're both negative. X and Y are both negative, so that would be a positive. And then express cosine 130 in terms of theta reference. So the cosine of 130 here is to be 40 degrees past the 90 here. That'd be 130. And then here's your reference angle will be right here. So 180 minus 130 would be a 50 degree reference angle for this here in cosine. And cosine would be the x. So cosine is negative in quadrant 2 because your x values here are negative. So it'll be a negative cosine 50 degrees. Sine and cosine tangent and cotangent and secant and cosecant are cofunction pairs. Cofunctions of complementary angles are equal. If alpha and beta are complementary, then trig alpha equals cotrig beta and trig beta would equal cotrig alpha. If both angles are acute and sine 3x plus 20 degrees equals cosine 2x minus 40, find x. So for this situation, since these cofunctions are equal, the angles must be complementary. Therefore, 3x plus 20 plus 2x minus 40 would have to equal 90 degrees in this situation here. So 5x minus 20 will equal, when we combine like values here, 5x minus 20 will equal 90. So x would have to equal 22 degrees in this situation here. Although the degree is the chief unit used to measure an angle in elementary mathematics, radian measure has several advantages in more advanced mathematics. A radian is one radius length. The circle shown in the figure below has radius r. And where is that circle? Let me bring that up here. So here's your one radius here, which equals a radian. The circle shown in the figure below has radius r. So the length of this would be a radius here. And then this radian will be the same length as a radius here. The circumference of this circle is 360 degrees, or 2 pi radians. So 1 radian is 360 degrees divided by 2 pi, which is about 57.3 degrees. And so this angle here, 57.3, would equal 1 radian here. So 2 pi times this radian would be the complete circumference of the circle. Okay, everybody, so let's move on to our next situation here. In each of the following, convert the degrees to radians or the radians to degrees. If no unit measure is indicated, radians are assumed. Okay. So we got 30 degrees here. What do we need to do? We need to convert the degrees to radians. So to do that, we need to multiply by pi over 180 degrees. So 30 degrees would equal 30 degrees times pi over 180 degrees will equal pi over 6 radians for that one. And then 270 degrees, to do that one, 270 times pi over 180 will equal 3 pi over 2 radians. And then pi over 4, and then we're starting from radians now, moving back into degrees. So we multiply this by 180 over pi. So pi over 4 times 180 over pi will equal 45 degrees for this pi over 4 radians. And then we got 17 pi over 3. Again, we multiply by 180 over pi. 17 pi over 3 would equal 1020 degrees. And then we just have 24, so this would be radians here for 24. 24 times 180 over pi will equal 4320 over pi, which comes out to 1375 degrees here for 24 radians. And that was Chapter 7, SAT Math Level 2 Prep. Animated PowerPoint math video at AOL.com for course materials or questions. Thank you very much.